Next topic is looking at the required sample size that we need. And there are two formulas for the required sample size. One is for the mean. This is the formula for the mean. And then we have the formula for the proportion. So you need to know which situation you're in so you can use the right formula to get the required sample size. So example 3, how large a sample size will be necessary to estimate the true proportion of sales invoice containing errors in a large population within plus minus 7% with 95% confidence. Assume a pilot sample yields p equals to 0.15. So we're looking for how large a sample size that is required. So we're looking for sample size. And there are two formulas for required sample size. So we need to know which situation we're in. And how we know which situation we're in is because we're given the sample proportion. P is your sample proportions. So once we know that we're given sample proportions, so therefore we're in a situation of proportions. So we're going to use this formula. N equals to z critical square times pi times 1 minus pi divided by error square. And for the pi, we're going to assume that pi equals to p. So your population proportion equals to your sample proportions. And the second variable that we have is your error term. Error term is plus minus 7%. That's your E. So plus minus 7%. So error term here is your 0.07. So in this formula here, we have the pi. Pi is 0.15. And then we have the E. E is your 0.07. And then all we're missing is the Z critical. So how we calculate the Z critical? Z critical is norm.s.inv. So this is the formula that you need to know to calculate the Z critical. So previously we learned the formula norm.inv. So norm.inv will help you get the x. And then norm.s.inv will give you the z. It will give you the z value. And that's norm.s.inv. And the probability that we're going to use is alpha over 2. And we know that we're looking for 95% confidence interval. So our alpha is 5%. So therefore alpha over 2 is 0.025. So when we plug it into norm.s.inv, it will ask you for one variable, the probability, which is your alpha over 2. And we're going to put in the alpha over 2, which is 0.025. If you plug that into Excel, you're going to get negative 1.96. So I'll show you that really quickly. Equal norm.s.inv, open bracket. It will ask you for the x, which is your probability. So probability is your alpha over 2, so 0.025. You close the bracket, you're going to get negative 1.96. Once we calculated the Z critical, which is negative 1.96, then now we can plug it into the formula to get N. So N equals to Z critical square, so 1.96 square, times pi, which is 0.15, times 1 minus pi, so 1 minus 0.15, divided by your E square. So your error term square. So error term is 0.07 square. If you do that, if you do the calculation, you're going to get approximately 100. And that's your answer for example 3.